This lesson is for rationalizing the denominator. It's a skill that we'll need as we're doing our upcoming trig units. So it's a good thing to learn now. So there's a math rule that says that you cannot have square roots in the denominator. No square roots in the denominator. So rationalizing the denominator means to get rid of the square roots in the denominator. It's the mathematical way of saying get rid of the square roots in the denominator. In order to do this, all you have to do is multiply the numerator and denominator, both of them, by the square root. All right, let's take a look at the first example. The directions say express in simplest form with a rational denominator. Rational means no square root. Example 1, 2 over square root of 5. So we're going to multiply by the square root at the bottom and at the top, numerator and denominator. What you end up with in the numerator is the 2 and the square root of 5 cannot actually multiply together because they're not like terms. So you just leave them sitting next to each other like this. Then in the denominator, you have the square root of 5 times the square root of 5, and that actually gets us the square root of 25. The good thing is the square root of 25 just turns into 5. And then 2 radical 5 just stays 2 radical 5, and you finish up the problem like that. After you do a couple of these problems, a lot of students often skip the step where they write the square root 25, because every time you multiply a square root times itself, for example, you multiply square root of 5 times square root of 5, you always get regular 5. All right, let's take a look at the second one. 8 over square root of 7. So multiply by square root of 7 at the numerator and denominator. I'll get 8 square root of 7. Again, can't combine those, can't actually multiply them. And I'll get the square root of 49. Square root of 49 is 7. So again, you can see how some people start to skip that step of writing square root 49 because they know it's always going to come back to that original number. Example 3, multiply by square root of 2, square root of 2. Take a second and see if you can finish this one. All right, 3 radical 2 over 2 for a final answer. And the last one, multiply by square root of 10. And I'm going to go ahead and skip that step. And I'm just going to write 1 square root of 10 over 10. Again, I'm kind of skipping the step of multiplying the radical 10 times radical 10 to get the 100 and just square rooting that 100 down to 10. You can do that if you'd like. Now, oftentimes, if there's a number 1 in front, you actually don't need that. So you could write this as square root of 10 over 10. That's a good final answer. All right, for the next 4 problems, it's going to be the same thing, except at the end of these problems, we will need to reduce it. So 4 square root of 10 over 10. Same thing. Again, if you're confident skipping that step, I know 10 times 10 is 100. Square root that number gets us down to 10. Then we're going to take the numbers 4 and 10, so the numbers that are not in the square root bar, and we're going to reduce that. So when you reduce the fraction 4/10, both of those can be divided by 2, and you get the fraction 2/5. Now, the square root of 10, you leave alone. You do not reduce that. So 2 square root of 10 over 5. Don't reduce the square root. All right, next one. 2 over square root of 6. See how far you can get into this problem. Again, it'll be a reducing at the end. Right, 2 radical 6 over 6. We're going to take the 2/6, reduce that fraction. Both of those can be divided by 2. And it's not always 2. Sometimes they can divide by 3 or 5 or whatever. But 2/6 reduces to 1/3. Bring over the square root of 6. And again, just like on problem number 4, we don't need that 1 in front. So I'm going to write this as a final answer, square root of 6 over 3. All right, example 7. Always multiply by the root. 5 square root of 5. Then the denominator, 5 times 5, 25. Square root that. Get back down to 5. On this one, we're not so much going to reduce as actually just cancel out. So these numbers in front, 5 and 5, you divide those out. They get you 1, cancel it out. And then you're just left with square root of 5. And our last one, example number 8. Radical 3. 6 radical 3 over 3 times 3 would be 9. Square root that to get 3. Take the outside numbers, the numbers not in the square root, and reduce them. This time they divide evenly into a whole number. 6 divided by 3 is 2, or if you like, 2 over 1. So you could write it over 1 if you wanted, but most often you'll see it without the 1 in the denominator.